Composition functions, Algebra 2, trigonometry regions. So in the previous video, we learned how to evaluate something like h of 4. Select the pen here. H of 4 given the function h. This is basically just a composition of functions, or a composite function is kind of just a combination of two functions. And so what you see here is g of h of 4. And when you have this type of formation, when you have a function of a number kind of thing, you work your way inside to out. So you first want to evaluate what h of 4 is and figure out what h of 4 is, because you're doing g of that. And so h of 4 is evaluating 4 plugged into h. And the input rule for h is whatever I do to my input, I am going to cube it and minus 1. It's a little sloppy, but I want to rewrite that. Because remember, h of x you could think of as h of in, and then your x stands for your input cubed minus 1. So it's my input cubed minus 1. So that's going to be 4 cubed minus 1. And 4 cubed is 64. Minus 1 equals 63. So that means that h of 4 equals 63. So if I want to do g of h of 4, I have to do g of 63. And my rule for g is whatever I do for my input in g, it's the square root of my input. And so that's going to be the square root of 63, which does not get simplified, and so simply that's my answer. So really it's kind of just like 2 rounds of evaluating functions. You know, you do this first and then you do that second. But sometimes we get this little bubble notation, which you saw in geometry last year when you had something like, you know, translate by some vector, the little bubble, rotation 90 degrees of the coordinate, you know, 5, -2. And if you remember back in geometry, what you did was you worked left to right, which is a little strange because we always go right to left. Like sorry, I switched that around. We always go left to right. Like we read on the left side of the page to the right side of the page, and we write, you know, if f of x, that's left to right. But when you have this little bubble symbol, you go in reverse. You go right to left. So you first do this, and whatever that is, then you do this. And so you should be familiar with this because you did it last year in geometry, but it's the same thing here. So when I see f of g, that is not the word fog. It's f of g. It's the little bubble symbol. You do the g first, or you do whatever's to the right of first. It could be g of f, or it could be g of g. You know, it doesn't really matter. Whatever's over here, you do that first. So I first need to evaluate g of 8. And so g of 8, the rule here for g is whatever I plug in is going to go in here. I'm going to double it and square root of that. So square root of 2 times 8, that's the square root of 16, is 4. And so whatever I get here, in this case 4, I'm now going to do f of that. And so I'm going to do f of 4, which is, let's see, what's the rule for f? The rule for f is whatever I plug in, I square it and I times it by 5. So it's 5 parentheses my input squared. Remember, x just stands for a placeholder of input. Whatever you're plugging in for that function replaces your x. And so in this procedure here, you do exponents first. So that would be 5 times 16. 4 squared is 16. And 5 times 16 is 80. And so you'll see it both ways. Sometimes you'll see parentheses, parentheses. In that case, you work your way in to out, which again, in this case, means you go right to left. Or if you have the little bubble symbol, remember you do the bubble first, and the expression to the right of the bubble first, and the expression to the left of the bubble second. Just one more quick example that, how about if we had a composite function like this, but instead of plugging in a number, you plug in an x. And so this question, I have f of x, and remember what this is really saying is my input rule for f is whatever I plug into f, I do 3 times it, minus 1. And my rule for g, my input rule for g, is whatever I plug into g gets squared, and then I minus 4 times whatever I plug in for g. Because remember, your x stands for input. So it's input squared minus 4 times input. So what you're doing here is, again, it's the same thing like this, where I work with what's inside and I work right to left, except I'm not plugging in a number into G, I'm plugging in an X into G. And plugging in an X into G is this. I already have it here. G of X is X squared minus 4X. A mistake students make sometimes is they think like, all right, well, doesn't it become X cubed if I plug an X into G? Remember, it's not that you're plugging in an additional X. These X's are replaced by whatever's here. So if I have an X here, I have an X here. If I have an A here, I have an A here. If I have a C here, I have a C here. You know, like G of D would be D squared minus 4D. G of 5 would be 5 squared minus 4 times 5. So G of X is X squared minus 4 times X. So G of X is simply G of X. And I now want to plug that into F. So now I'm doing F of G of X is F of the expression I get from G of X. So I'm doing F of X squared minus 4X. And my rule for F, I stated up here, is whatever I input is 3 times my input minus 1. So that's 3 times my input, X squared minus 4X minus 1. You can simplify this a little bit. Distribute is 3x squared minus 12x, and then I still have a minus 1 on the end. And I'm not asked to solve this or anything like that. I have an expression for f, I have an expression for g, and I'm trying to create a third new expression by plugging these two functions into each other. So 3x squared minus 12x minus 1 is the answer. That's it. Practice this tomorrow. See ya.